All right, 7th grade, we are ready for our last lesson of topic 10 before we start reviewing and pulling it all together. So today we're looking at 10.5, which is our lesson over vertical angles. So our last set of angle relationships. We've talked about adjacent. Adjacent angles, remember, are next door neighbors. They share a wall. It's like they're duplex neighbors. We've talked about complementary, two angle pairs that add to 90. So if they're adjacent and complementary, then they form a right angle. We talked about supplementary angles that add to 180. So if they're adjacent and supplementary, they form a straight line. And today we're going to talk about vertical angles. So these you might kind of be able to guess since we've already talked about next door neighbors. Now we're going to talk about angles that are opposite of each other. So for our learner's question, we could ask, how do I use vertical angles to solve problems? You are probably remembering that a lot of our homework has been finding angle measures and solving for x. So we're using those angle relationships, and that's what we're going to continue today. So for some of our key terms, let's fill in these blanks. Vertical angles are formed, that should say formed, sorry about that. Vertical angles are formed by two blank line and are blank each other. So when we look at our diagram here and we see that angle 2 and angle 4 are vertical angles, both of these angles, this one and this one, are each formed by two intersecting lines, right? If we look at this is one big long line and it's intersected by this long line and it forms these two angles. So the word we need in this first blank is intersecting. And I'm going to have to write it diagonally so I can fit it. So vertical angles are formed by two intersecting lines and they are opposite each other. So they're not next door neighbors this time. The only thing they have in common is their vertex. So vertical angles, because they're formed by the same lines, they always have equal measures. So if this angle is 60, then this angle is going to be 60. So that's kind of a nice relationship for us to remember. They're just going to be the same. And we can tell because they generally look the same too. So let's look through this diagram. Let's look for some angle pairs that are vertical. So for example, I'm going to look at angle 1 here. I see an angle that is opposite of angle 1, and that's angle 2. But these angles aren't both formed by the same two lines. This line makes up half of each angle, but this line only forms the other part of angle 1, not the part of angle 2. So these aren't vertical. The same is true of angles 3 and 4. They're opposite of each other, but they're not formed by the same two lines. Right? This line is part of both angles, but this line is only part of angle 4, and this line is only part of angle 3. If I jump down here to angles 5 and 6, though, I can see they're opposite of each other, and they're both formed by the same two lines. These two green lines I've just drawn intersect each other and give us angle 5 and angle 6. So that would be one pair of vertical angles. And if I look at angles 7 and 8, I can see they're opposite of each other, and they're both formed by these two lines. So angle 7 and angle 8 would also be vertical. So not only do they have to be opposite each other, they have to be formed by the same two intersecting lines. On this next diagram, we're going to name the angle that is vertical to angle ABC. So first let's find angle ABC. I see A, B, C. So what I'm going to do is I'm going to start at A and I'm going to extend this line out. And I'm going to start at C and extend this line out because I need the angle that's formed by these two lines and is opposite of this angle here. So that's going to have to be this angle. See how they're opposite each other and they're both formed by the same two lines. So this would be angle RBW. Or you could call it WBR. That angle would be vertical to angle ABC. Now let's take a look at how to use this angle relationship of vertical angles to find the value of x. So in our diagram here, I notice a couple things. I've got this angle, that's 5x degrees. I've got this angle, that's 40 degrees. And this is part of a complementary pair because this angle is a right angle. So I'm going to use what I know to help me figure out what I don't know. So if I need to find the value of x, I need to look for an angle that I know the measure of that can help me. If I know that we're studying vertical angles, I'm going to go ahead and look for a vertical angle right off the bat. So as I'm looking at TYD, I notice that there is an angle opposite of it that I can find the measure of. So this would be a vertical angle to TYD. See, these are opposite of each other and they're both formed by the same two lines. So whatever the angle measure is of this, UYH, that has to be equal to this measure, TYD. And the reason I'm going to use this vertical angle is because I know what this is. If this angle altogether is 90, then I'm going to use what I know about complementary angles to help me figure out that this must be a 50-degree angle. Because if this piece is 40 and this whole thing is 90, then this must be 50 because 40 plus 50 is 90. So if this angle equals 50 and this angle equals 5x, then I know that those two values must be the same because they're vertical angles. So now I have a one-step equation to solve. If I want to get x by itself, I'm going to divide by 5. Whatever I do to one side, I have to do to the other. So I'm going to cancel those. 5 divided by 5 is 1, which leaves me just with the x. And 50 divided by 5 is 10. So x must be 10 degrees. This one's a little more complicated because we used both vertical angles and complementary, but let's take a look at another one here with our skier. This goes right along with the Winter Olympics. And let's practice it one more time together. So the way his skis are crossed, or she, can't tell if this is a guy or girl, this is forming an angle that's 140 degrees, and then we know that this angle is 4x plus 40. Well, these are vertical angles, right? They're both formed by the same two intersecting lines, and they're opposite of each other. So if this angle is 140, this angle must also equal 140. So if we're calling this 4x plus 40, I'm going to set that equal to 140 and now use inverse operations to solve. So if I want to get x by itself, I'm going to undo my addition subtraction first. 40 minus 40 is 0, so all I have left over here is 4x. And 140 minus 40 is 100. Now to get x by itself, I'm going to divide by 4 because that's going to undo the times 4. If I divide by 4 on this side, I have to divide by 4 on this side. 4 divided by 4 is 1, which leaves me just with the x because 1 times x is x. And 100 divided by 4 is 25. So x equals 25 degrees. All right, for our final question I leave you with to talk about in your table groups is, can vertical angles be supplementary angles? So can they be vertical? Can they be opposite of each other, but also be supplementary? Maybe think of an example that works, or if you can only come up with examples that won't work, maybe you could use that to support your claim. So let's talk about these questions in our table groups. Can vertical angles be supplementary? And then let's decide if they can also be acute, right, or obtuse. So we will talk about that together, and then you can start your 10-5 homework.